Okay, so in today's lesson, we're going to be talking about atomic structure. Okay, so basically, we're going to describe the general structure of an atom and the distribution of electrons. We're going to differentiate between an atomic shell and an atomic orbital. We'll also describe the atomic structure of hydrogen, carbon, oxygen, nitrogen, phosphorus, sulfur, sodium, and chlorine, and describe the nature of covalent and non-covalent chemical bonds. Alright, so let's get straight into it. So the first thing that we're going to talk about is the general structure of an atom. Okay, so we're basically talking about an atom. Now when you look at an atom, all atoms are building blocks of all matter in the universe. So an atom is a basic building block of all matter. Okay, so this is to tell you that whatever you see in the world is made up of atoms. Okay, and having said that, we must also know that an atom is made up of electrons, a nucleus, which are comprises of protons and neutrons. Okay, so we're going to see how exactly these come about. So we'll look at the basic structure of an atom. So if this is an atom, it's going to have a nucleus in between. Now in this nucleus, we're going to have what we call protons and also what we call neutrons. And around it, we have what we call electrons. Now, all these elements of the atom have charges on them. So electrons actually negatively charged, protons are positively charged, while neutrons, they have no charge at all. Okay, so this is a basic structure of an atom. And then the other thing that we're going to talk about is how these the function of the basic units of an atom. So when we look at electrons, electrons are actually one of the lightest. So they're very light, and they are found to be orbiting around the nucleus. So what it means to orbit is, it means to encircle. So this electron goes around the nucleus. Okay, but when we look at the protons and the neutrons, these two, we have the protons and the neutrons, they're actually stationary. Okay, so these do not move. The only thing that moves are electrons. Okay, so we're going to see the importance of actually the movement of these electrons that we have actually highlighted. All right, so the next thing that we're going to talk about is the hydrogen molecule. Okay, so when you look at hydrogen, we know that hydrogen only has let me just draw it here. Hydrogen has one proton and it also has one electron in the shell. Okay, so when hydrogen is bonding, for instance, this is the hydrogen shell, it will only have one electron and the other electron. So when these two electrons actually share, we'll have what we call the hydrogen atom. Okay, all right, so having said that, I also want us to look at what exactly is atomic number, what is mass number, and so on and so forth. So when we look at atomic number, okay, when you look at the periodic table, you will realize that there are certain elements, for instance, sodium, where we have 11 and 23. So this number that you're able to see, this is the atomic number. Okay, and then the number above is the mass number. Okay, so it determines the mass. Now, in order for us to determine the mass number, we must add the atomic number, which is also called the proton number. Okay, so the proton number is simply the number of protons in that atom. So we add the proton number, which is 11, plus the number of neutrons, which is going to be 12. Okay, so to give us the mass number, which is going to be 23. So this is to tell you that when we add the proton number, the number of protons, plus the number of neutrons, they'll give us the mass number. That's exactly how we're going to find this. Alright, now we also need to know and to learn that it's only electrons are able to participate in a chemical reaction. Okay, so whenever you see any chemical reaction, you must remember that it's only electrons that are actually able to participate in these chemical reactions. Okay, so our next objective is actually going to be talking about the difference between an atomic shell and an atomic orbital. Okay, so look at orbitals and shells. So what exactly is an orbital? So an orbital is a region, it's a physical region where an electron is expected. Okay, so a basic example that I can give you is that when you look at an orbital, a shell. Okay, so a shell is the pathway. So a shell is simply a pathway. Okay, so it's a pathway through which this electron orbits the nucleus, or rather surrounds the nucleus, or moves around the nucleus. That's the shell. But when you look at the orbital is actually it's specifying the region where we are most likely to find that electron. So this is what we are calling orbital. Okay, so the difference between an orbital and a shell is that for a shell, it is simply the pathway through which the electron uses to orbit this nucleus, while an orbital is the physical region where an electron is expected to be found. Okay, so we're going to go more in depth as we look at an orbital and the shell. Alright, so orbitals exist at different energy levels, which can be the lowest to the highest. So what I mean is that an atom can have two shells, right? So the orbital, which is in the first shell, has lower energy than the orbital in the second shell. Okay, so what I want you to know that in every shell there's a specific number of orbitals that you can find. So in the first shell you only find one orbital, okay, which we also call the s orbital. In the second shell you find 3 orbitals. Okay, so in the second shell we'll have 2s, which is the lowest orbital. Actually, in the second shell we'll have 4 orbitals, because we have 2s and 2p x, 2p y, 2p z. So these are orbitals. So let me just illustrate that. If this is the first shell, we call it s, just one s. Now within the second shell it has levels. The first level is 2s, then the higher you go it becomes 2px, 2py, and 2pz. Within this second shell we have more orbitals, okay, and you must know that in every orbital we can expect an electron to be found, okay. So having said that, the maximum number of orbitals the maximum number of electrons that you can find in an orbital is just 2 electrons. So if there are 3 orbitals, you can only fill those orbitals with 2 electrons, 2 electrons, and 2 electrons. That's how it is. So the orbital with the lowest energy is the s orbital, okay, like I have been highlighting. Let me just now go in depth about these orbitals. Okay, so the lowest energy orbital is the s orbital, okay. So that's done with the lowest energy. Then the next orbital is what we call the p, or rather principal orbital. So orbitals actually arranged in form of shells in which the innermost shell has one s. Like I said, the first shell only has one s, and one s we said is the lowest energy level orbital, okay. So this is to tell you that the electrons which you find in this 1s, and you know that this 1s is found close to the nucleus, okay. So you have learned that protons are positively charged, electrons are negatively charged. So this is to tell you that the closer a positive charge is to a negative charge, the greater the force of attraction, because these two charges are opposite. Hence the electron, which is the first shell, will be the lowest because it has less freedom to move around the nucleus due to this force of attraction, which pulls it towards the center, unlike electrons which will be further apart, okay. So the further an electron is from the nucleus, the more energy to have to actually even be able to go out of the atom at some point, okay. Having said that, we also look at the second shell has 4 orbitals, okay. So the second shell will have 4 orbitals, all right. So the first orbital, like we said, the lowest energy orbital will be 2s, and it will have 2p orbitals. So this is to tell you that it moves like the first level is 2s. This is within the second shell. The other orbitals we have are 3, 2, 2, 2. Now these 3 orbitals we have 2px, 2py, and 2pz. Notice that all these orbitals are found in the second shell, okay. They just have different energy levels. So this is to tell you, if an electron is in the 2s, it needs enough energy to jump into the 2px, and then the 2py, and then the 2pz. So when you look at this, there are certain electrons which are found in the same energy level. We call these electrons degenerate, okay. So these electrons are called degenerate because they are found in the same energy level, all right. So it's like the energy that is found here, it's the same, okay. So we can even imagine this like a staircase. So you have the first staircase there, the second, and then the third, and so on. So the first staircase has lower energy, which is 2s. For you to move to the second stair, you need more energy. Now we're saying that if you move to this second stair, you keep on moving, you will not spend any energy because you are in the same energy level. Hence, electrons that are found within this energy levels are called degenerate because they occupy the same energy. Okay, all right. Okay, so this is all about an orbital and the shell. Okay, the next thing that we're going to talk about is electron chemical bond. So while talking about chemical bonds, we're going to highlight them first. We have what we call covalent bonds. We also have what we call non-covalent interactions. And we also have ionic bond. Alright. So having said that, let us just go in depth and get to talk about these bonds individually. Okay, so having talked about electrons and the orbitals, this is going to help us appreciate actually to see how chemical bonds take place. Okay, so the first one that we talk about is the covalent bond. Okay, so firstly we'll start by defining exactly what do they mean by covalent. So when something is covalent, it means there is some sort of cooperation. Okay, so this is to tell you that it's a bond which is formed between atoms. Okay, so a covalent bond is a bond which results from equal sharing of electrons between two atoms. Okay, so for example, hydrogen has one electron, another hydrogen also has one electron. So these two atoms are going to share electrons in order to form a bond, which is the hydrogen molecule. Okay, so it is the equal sharing of electrons in order to form a bond. If the electrons that are being shared are not equal, then that bond is not a covalent bond. Okay, so a single covalent bond represents sharing of two electrons. So this is going to be a single covalent bond. If you want to illustrate it, you may even write it like this. This bond is called a single covalent bond. Okay, so it's a single covalent bond. So it will only have two electrons. Okay, and then we also have what we call a double covalent bond. Okay, so also have what we call a double covalent bond. Okay, so when you look at this, it means there are two atoms that are sharing two electrons among themselves. For instance, oxygen and another oxygen. Okay, so we know that oxygen has 6 2 3 4 5 6 4 5 6. Okay, so it has 6 there. So in order for oxygen to actually become a stable atom, because for an atom to be stable it must have 8 electrons in its shell. So this is why you get to learn about electron configuration, where you can use this formula, which is 2n squared, to find the maximum number of electrons that can occupy a shell. Okay, so now oxygen can bond with itself. Okay, they can actually fuse in order for them to make an oxygen molecule. Now that bond between oxygen and oxygen is called a double covalent bond because there are 4 electrons. Okay, so this is to tell that a single line has 2 electrons. Okay, this single line that you're able to see that has been illustrated will have 2 electrons within itself. Okay.